Very well. This is for Marta. This is from the Revision Village predicted exams, and we're looking at a functions question. So the first one is that f right here, f, the tangent to f has this equation. So that therefore, what this means is that the derivative of f at x equals 3 is equal to the slope of the tangent line. So very simply then, this is why it's only worth 1 point. F prime of 3, which is equal to the slope of the tangent line of f at x equals 3. So just to be clear, the slope of the tangent line, which is f of x. We don't have f, but we do have the tangent line. If we look at the tangent line, we see that it's equal to 4. So f prime of 3 is equal to 4. B, to find f of 3. Well, if we antiderive f prime, we should find f. So if we antiderive f prime of x, we're going to have f of x plus c. So in this case, I'm going to antiderive 4x minus 2 dx. This is going to equal to 4x squared over 2 minus 2x plus c. And this is my f of x, and f of 3, therefore this is equal to f of x. F of 3 in this case would equal, well, 4 times, so this is 2x squared. This would be 18 minus 6 plus c, which is equal to 12 plus c. Very well. Now that doesn't actually answer this explicitly. Just define the tangent as an equation. Well, the other thing we can notice, this is perhaps much simpler, I made my life more complicated than it needs to be, is that the tangent line and the graph have to touch at x equals 3, so that this function right here and f share the same coordinate. So said differently, f of 3 more simply is going to equal y of 3, which is 4 times 3 minus 2, which is 12 minus 2, which is equal to 10. I did not need to do this part right here, and you'll notice that as I did that, it did not give me the answer I was looking for. Very well. So let's just be clear that this right here is actually all that was necessary when you remember that the tangent line touches your original graph. Very well. Now we move on to C. The function g is defined for all x belongs to the real, where g of x equals this, and h of x equals f of g of x. Very well. So h of 2 is going to equal to f of g of 2. Well, I'm going to start by finding g of 2. It's going to be 11 minus 2 times 2 squared. So 11 minus 8, which is equal to 3. And then this is therefore equal to f of 3. And f of 3, well, we just found f of 3. F of 3 we found above in B. F of 3 is 10. So h of 2 is equal to 10. And then in D, we're finding the equation to the tangent of the graph of h at x equals 2. Well, h of 2 equals 10. So we've got this coordinate for h, and we want the equation to the tangent. Well, h of x is equal to f of g of x. Therefore, h prime of x is equal to f prime g of x. This is the chain rule. Be careful here. That is g prime of x. And at x equals 2, h prime of 2 is going to equal f prime of g of 2 times g prime of 2. And g of 2 we found up here was 3. So this will equal f prime of 3. This we've seen now show up a few times. Sorry, this is g of 2 times g prime of 2, and we're going to find g prime of 2 right afterwards. G prime of 2. F prime of 3 we found was 4. And let's do g prime of 2 right now. G prime of x is equal to minus 4x. Therefore, g prime of 2 equals minus 8. So f prime of 3 times g prime of 2 is 4 times minus 8 equals minus 32. And I believe this was, oh no, I haven't found it yet, sorry. That gave me my derivative right there. So now for the equation of my derivative, I'm going to have y minus h of 2 equals h prime of 2 x minus 2. This is the equation of my tangent line using the point slope form, which I like. You don't have to, you can use a different form if you'd rather. So this is y minus 10 equals minus 32x minus 2. And this is actually a valid, but just in case you'd prefer the other one, I can have y equals minus 32x plus 64 plus 10 minus 32x plus 74. And I think this clarifies that's the equation to the tangent of the graph h at x equals 2. And we used h of 2 and h prime of 2 at x equals 2, which I think satisfy the requirements. I hope this helped.